Hi, this is Mr. Williamson, and this video is about matter. As usual, I would suggest that you take notes during the video. Make sure you stop it and rewind it if you need to. Go back and rewatch sections that you don't understand. If you're watching an Edpuzzle, make sure you answer the questions completely. One-word answers are probably not going to be satisfactory. And again, if you have any questions in the video, make sure you ask me during class. I'll be glad to answer them for you. Matter is anything that takes up space and has mass. For instance, we have a measuring cup over here. No matter what we put into it, if it's a gas, liquid, or solid, we can measure its volume. So all matter has volume. Or we could also think of it as it takes up space. So all matter takes up space and has volume. We also can find the mass, so we can put it into a scale and find the mass. So it has mass. Having mass means that like on Earth, we can weigh it. On Earth, we don't really call it mass as much as we call it weight, because there's an attraction of gravity on the mass, and we assign the word weight to it. But all matter takes up volume and has mass. There are three states that matter. The three states that matter are California, New York, and Delaware. California, obviously, because, well, we live here, and it is, a good state. New York, pretty popular, and Delaware was our very first state that signed the Declaration of Independence. And it's also where my sister lives. Really doesn't matter. It's a really small state. Not important. That's a joke, by the way. The first state of volume is gas. Gas is a state of matter that has no definite volume. And it also has no definite shape. You can see here I've got helium in this tank. This tank over here. The helium here, it's He. We would fill up balloons. Now, right now, that helium is in the volume of the tank. It takes up the space of the tank, and it takes up the shape of the tank. When we take that amount of volume and we put it into the balloon, it now takes up the shape of the balloon, and it takes up the volume of the balloon. So the volume is changed and the shape is changed. And then when we take that, let's say you inhale that helium and talk really strangely high voice because it changes your vocal cords. Now the shape of the helium is the shape of the lungs, and the volume of the helium is the shape of the lungs. When you exhale that helium out of your lungs and take a normal breath, now the helium takes up the shape of the room and the volume of the room. In other words, we've moved it from the tank size and volume, and takes up that much space, to the balloon's shape and volume, to the lungs' shape and volume, and then finally to the room. In other words, it has no definite shape or volume. It will change with its container. Liquid has a definite shape, has definite volume, but no shape, or no definite shape, I should say. All right, you can see here the carton of milk. The milk is in the shape of the carton, and let's say that's a quart, which it is right there. It says quart. That's a quart of milk, and it's in the shape of the container. If we move that milk into the glass, and the glass held a quart, it would still be 1 quart, but now it's in the shape of the glass. If you spill that glass onto the counter, you still have a quart, but now it's in the shape of the spill. So it has a definite volume. It always stays 1 quart, but it has no definite shape. It takes the shape of what a container it's in, but it's going to be always the same volume. The last one that we're going to talk about in this class is a solid, and the solid has It has definite shape, and it has definite volume. Meaning that we can't really change the shape or the volume. This piece of obsidian is basically, it's volcanic glass, is going to be that shape forever. Now we can break it into pieces, but it will remain that shape, and it will continue to take up that same amount of volume. If we break it up into smaller pieces, it will still take up the same amount of space as it did when it's a solid piece. It would just have space between the pieces, but it will always stay the same shape and same volume. So again, gas has no definite shape, no definite volume. Liquid has no definite shape, but it does have definite volume, and solid has a definite shape and its definite volume. All matter is made up of atoms. The smallest unit of matter is an atom. The smallest unit of matter is an atom. You can get smaller parts of an atom, but that's not the smallest part of unit of matter. We can make, then we're going to talk about this, the protons, neutrons, and electrons, and but they don't take up shape. They don't take up volume, and they don't have mass. An atom is the smallest thing that has mass and has volume, and so the smallest unit of matter is an atom. The parts of an atom are, there are three parts. We have electrons, we have protons, and we have neutrons. And I'm going to talk about each of those. What you will notice is that the number of protons is always, or usually, if for a normal atom, is equal. So there's the number of positives equals the number of negatives. Equals the number of negatives. That gives the overall charge of an atom a neutral charge. It's not a positive, it's not a negative. Now I'm going to show you there are not exceptions, but there are ways to change that. But the overall charge of an atom is neutral. So the overall charge of an atom is neutral. The parts that we're going to talk about are the electron, the proton, and the neutron. Okay? And we need to know about those because those actually affect the way the different atoms and the chemicals react. It's those particular particles. So the first two we're going to talk about are protons and neutrons. You can see, for instance, this is hydrogen, and you can see the atomic number is 1 if you look at a periodic chart, which we're going to talk about in a few moments. The atomic number is 1, the number of electrons is 1, the number of protons is 1. The atomic number is always equal to the number of equals the number of electrons and the number of protons. These are negatively charged, these are positive charged, and that's why the atoms are neutral. You can see over here, you can see helium, which is the number 2 on the periodic chart, has 2 protons and has 2 electrons. We can take a look at lithium, which is number 3, has 3 protons, 3 neutrons. Neon is atomic number 10 and has 10 protons and 10 electrons. So the protons and electrons are always equal. You'll also notice that the protons are positive, so we're talking about here protons. They are positive in charge, they have a positive charge, and they're found in the nucleus. The neutrons, protons are the blue ones in this case, the neutrons are neutral in charge. They do not have a charge. They don't have a positive or negative, and they're also found in the nucleus. that they're not always equal to the number of protons. And that, again, that's chemistry. That we're not talking about chemistry, we're talking about biology. What you need to know is the protons and the neutrons are found in the nucleus, and a proton has a positive charge. The electrons, well, I'm going to talk about them on this slide. The electrons are found in the outside orbital. They're found in here. They're in the orbital, or orbits. Sometimes they're called shells. And they have a negative charge. And the number of electrons equals the number of protons, like we talked about before. For every two, there's 2 protons, there's 2 electrons. There's 1 proton, 1 electron. There's 3 protons, 1, 2, 3, and there's 3 electrons. The number of electrons are equal to the protons, and they're found in the shells. Now, the thing is, they're really not shells. They don't. Most people think of atoms as being something like this. You have the nucleus right here, and then you have the ring of orbitals, an electron out here, an electron out here, and then you have the next ring of orbits, and the electron out here and the electron out here, and actually the next one holds 8, which I'm going to talk about here in a moment. They hold 8, or maybe you've seen it drawn something like this, where you have the nucleus and it's drawn kind of a shape like this, and while drawing on this is not easy, something like that. That's not really true. The electrons are more in a cloud. It's kind of like these birds here. You can see these birds, which are flocking and flying around, and they take up this whole space here. You can also see that it's much heavier in this area. Well, that's kind of like what happens in the electrons. You have the nucleus, which might be like right there, and the electrons, let's say the 2 in the innermost ring, will be found in this area most of the time. Kind of like you see the density of the birds. There's a lot of birds in it. But then they might be found over here, over there, but most of the time it's here. Then it's over here, over there, and then most of the time it's here. If you go to the second ring, there'd be another cloud here, kind of like this one, and they would be found out there. So they're not really like stuck in. They don't really rotate around. They kind of move around randomly, kind of like these birds, but they would be found more often in the outermost ring. So if we go back to this slide, you can see where we have these rings. So the innermost ring, the outer one, there's actually one out there that we're not talking too much about that, but we need to discuss a little bit. And we need to know that the innermost ring here holds 2 electrons. That's all it can hold. So there's 2 electrons there. The next ring, the second ring, can hold 8. 1, 2, 3, 4, 5, 6, and 7, and 8. Okay, and that it can only hold that. So that means that if this neon, which has an atomic number of 10, so it has 10 electrons, it has 2 on the inside, 1 and 2, and then has 8 on the outside. That gives a total of 10. Now, if it had 11, we would have to put another ring, and we would put one more into that one. And we need to know that, because when we start talking about how atoms bond, we need to know about the rings. But you need to remember that the innermost ring, inner ring, holds 2 electrons, and for our sake, in our class, all the rest. Now, it's not true. When you take chemistry, you'll find out that I'm not really completely honest in telling you the truth. But for our classes, what you need to know, all the rest hold 8. And so the innermost ring holds 2. All the rest of them hold 8. Remember that. For our class, that's what you need to know. And again, it's in this shape here, where, not shape, but this kind of idea where the electrons are more in one area than they are out in the other areas. All of the atoms that based on their number of electrons and protons are arranged in a periodic table. This is not chemistry, so we're not. I don't expect you to know the periodic table or know how to use it. That's a chemistry issue, and you will learn it there. But for instance, when we talked about hydrogen, you can see hydrogen's number 1. It has basically a proton, and around it an electron. Helium is number 2. It's way over here on the right, and it has 2 protons, and around that it has 2 electrons. All right, and we can take a look at this chart, and you can figure out like boron would have 5 protons in the nucleus. It would have 2 in the outermost ring, and then if we went around, the next one would have 3 electrons in the next ring. Okay, the one of the important ones that we need to talk about is carbon. We're going to do this in the future a little bit more, but why is carbon so important? Because carbon has 6 protons in the nucleus, and then around it has the 2, and then around that one, the second ring, it has 4. That gives it a total of 6. And that's what makes carbon really important in biology, is these 4 electrons in the outermost ring, and what it lets it bond with different things. But this is an element is basically the purest substance of matter. So for instance, when you have, let's say gold, AU number 79, when you have gold, if you had an element of gold, you would have pure gold. There would be no atoms of any other kind there. If you have silver, which is AG, you would have pure silver. So that's what we're looking at in the periodic chart. And the periodic chart, again, it's a chemistry thing. You learn a lot about it in chemistry, but we do kind of refer to it in biology. For instance, this periodic chart actually highlights the elements that are essential for humans. Like we know hydrogen is needed, we need carbon, we need nitrogen, we need oxygen. All the biological molecules that we're going to talk about in this unit, we talk about those: hydrogen, carbon, nitrogen, and oxygen. Ions are a form of atoms where what I just said does not exactly hold true. I said that the number of protons equals the number of electrons. Well, in this case, what an ion is, it's an atom that has lost or gained an electron. It's lost or gained an electron. And for instance, here you see 2 atoms, sodium, okay, and sodium and chlorine. Now you'll notice that again, if you look at it, the atoms, you have 2 on the innermost ring, you have the 1 here and the 1 here, and you have 8 on the next one. But sodium has this 1 over here. Well, atoms really like 8 in their outermost ring. That's what makes them happy. Chlorine, you'll notice 1, 2 on the innermost ring. You've got the 8 here, 2, 4, 6, and 8. And then you have 7 on the outermost ring. Okay, that leaves this 1 here. Well, it wants 8. So what will happen is this electron will travel over and attach itself over there. That makes this, if electrons are negative, remember electrons are negative charge, okay? If we take away a negative, sodium becomes a positive atom. If we add a negative, this becomes a negative atom. And like magnets, north and south pole attract, in this case, positive and negative attract, and the atoms are pulled towards each other. And that's actually how we get sodium chloride, which is table salt. That's the stuff that you put on your food, the crystals you put on your food when you eat. It's sodium chloride. It's 2 ions that are attracted to each other because of this negative charge and this positive charge caused by one of them losing an electron and one of them gaining an electron. So the last thing we're going to talk about is isotopes. Isotopes are atoms that have lost or gained a neutron. And I apologize for writing over the writing. It's a neutron, not an electron, a neutron. And we talk about this when we start talking about finding out the age of rocks, dating rocks, which we do when we start talking about evolution and adaptation and things. That takes us to the end of the video. If you have any questions, make sure you ask me in class. Just to cover, make sure we cover, review what we covered. We talked about the states of matter, or what matter is. It has volume, takes up space, and it has mass or has weight. There's 3 states of matter: gas, liquid, and solid. Make sure you know what the definition of each of those are. We talked about an atom and the parts of an atom that we're going to talk about: the electrons, the protons, and neutrons. Electrons are found in the outer orbitals or cloud. The protons have and electrons have a negative charge. Protons have a positive charge found in the nucleus. Neutrons have a neutral charge, also found in the nucleus. We talked about elements, the purest form of matter, would have all the same kind of atoms. And then we talked about variations of those atoms. We talked about ions, atoms that have lost or gained electrons, and we talked about isotopes, atoms that have lost or gained neutrons. Again, if you have any questions, make sure you ask me in class. I'll be glad to answer them. Hope you're studying for the test. Good luck.